students, this is our third lecture of our chapter number 1, which is building and loading layout. Okay, so in the first lecture we will discuss about which are the types of load which we have to consider while we have to design any RCC structure. Okay, so in that lecture we have to discuss that there are total 7 loads are there, in which first load is dead load, and the dead load calculation is as per IS 875 part 1. Second one is live load, and you all know that live load is also called as imposed load. So the calculation of imposed load is as per IS 875 part 2. Third one is wind load calculation. Now wind load calculation is as per our new IS code provision, which is published on 2015. Fourth one is snow load, and it is already discussed in the last lecture that snow load is considered in the vertical dimension and in the vertical direction. So the snow load is calculated as per IS 875 part 4. Fifth load is earthquake load, and earthquake is also find out from your new IS codal provision, which is published on 2016. So it is IS 1893 2016. Sixth load is shrinkage and temperature effect, and last load is other loads, and other load calculation is given in IS 875 part 5. Okay, so one question asked in your GTU Viva that there are how many parts of IS 875? So the question's answer is 5. Okay, so for which load, find out for which load we have to use which type of IS codes. Okay, so this is your second question for GTU Viva. After completion of our first lecture, we will discuss about what is the design step of wind load calculation. So, in the last lecture, we have to discuss that there is total 3 steps, in which our first step is design wind speed. So the equation of design wind speed is given as Vz is equal to Vb, K1, K2, K3 and K4. This equation is given on page number 5 of IS 875 part 3 2015. Okay. So in the last lecture we will discuss that how to calculate Vb, K1, K2, K3 and K4. Okay, after finding out all this unknown, we have the value of Vz, and Vz is also called as Vd. Okay, so this is the end of our step number 1. Now our step number 2 is design wind pressure. So there is two equations are there to find out design wind pressure, and design wind pressure is denoted by PD. Okay, so first of all, we have to find out the PZ. So you can see that whenever you have to find out PD, there is four unknowns are there: KD, KA, KC, and PZ. So first of all, we have to find out PZ. So the equation of PZ is 0.6 into VZ square, in which VZ is the answer of our first step. Now, if we have the value, if we have find out the value of PD, then we have to find out another three unknowns, which is three coefficients. First one is KD. Now, this KD is our wind directionality factor, and you can see that if our building is triangular, square or rectangular, then our factor will be 0.9. But if our building is circular or nearer to circular, then our KD value will be equal to 1. Okay. Now second unknown is KA. So generally K is depend on a tributary area. Now what is tributary area? So it is already discussed that in the last lecture that our tributary area means center to center distance between a bay. Okay, so center to center distance between column is also called as bay distance. Okay, so whenever we have to find out tributary area, so these are the tributary area, and this is the respective value of area averaging factor. Now Third unknown is KC. So you all the students are moved to page number 16, in which it is clearly mentioned that the value of KC is 0.9. Okay. So students, in the last lecture we have to calculate our design step up to step number 2. Now we are moving further to our step number 3, which is design wind force. So students, design wind force having generally two equations. One equation is CPE minus CPI into AE into PD, but this equation useful in your next semester, in your 7th semester, in which there is a subject of design of steel structure. Okay, so in design of steel structure we have to find out a load on any industrial roof truss. Okay, so whenever we have to find out design wind force on any building, then we have to use the equation is CF into AE into PD. Okay, now if we have to find out the value of F, then we have to find out the value of CF. Now what is CF? So you can see that CF means force coefficient. Now force coefficient is find out from two method, because in your syllabus there is two types of examples are there. First one is when a wind load is acting on any RCC building. It means any residential building or any commercial building, which is high-rise building. Okay. And another is when the wind load is acting on any elevated water tank. And you all know that what is elevated water tank, which is studied in your last chapter. Okay. So your elevated water tank which is at a higher level. Okay, so there is two types of examples are there. First one is when the wind load is acting on any residential or commercial building, and in the second method when the wind load is acting on any water tank. Okay, so how to find out CF will be discussed in the next slide. Second is AE. Now what is AE? So AE is effective frontal area, and A's equation will be discussed in next to next slide. And what is PD? PD means design wind pressure, and design wind pressure is the answer of our step number 2. Okay, so you can see that this equation of design wind force is given on page number 32. What is force coefficient? So force coefficient is as discussed earlier that there is two types of examples, and the value of CF can be find out from page number 35, 40, 41 and 56. Effective frontal area having no any IS module provisions page. Okay, so there will be one direct equations, and if we are putting the value in that equation, when then we will get our answer of effective frontal area. And at last it is PD, which is design wind pressure. So design wind pressure is basically find out from page number 9 and in our step number 2. Okay, so now let us start how to find out force coefficient. So our force coefficients as discussed that there are two types of examples when the wind load is acting on any RCC building. Okay, so when the wind load is acting on any RCC building, then we have to refer page number 35. So you all the students are moved to page number 35, in which there is two graphs are there. Okay, so you can see that we have to find out CF. CF means this value is find out in YY axis. Okay, now how to calculate our CF and at which position we have to refer figure 4a or 4b. So you can see that it is clearly mentioned that over here that value of CF versus A by B. So this is CF and this is A by B. For H by B less than 1, it means this graph is refer when H by B having less than 1 value, and This graph will be referred when h by b greater or equal to 1. Now the doubt is what is h, what is b and what is a. So just right hand side of figure 4a there is two graphs are there, two figures are there in which first is plan. Plan means whenever you can see any building from the top of the view, then it is called a plan. So if you have see the plan, then there is two dimension L into B in which this dimension is called as A and this dimension is called as B. Okay. Now if we have the value of A and B, then we have to find out the value of A by B ratio, okay, which is on our x-axis. Now what is another is H by B. Now we have the value of B, but what is H? H means height of building including parapets. Okay, so height is generally seen whenever we have to see from elevation point of view. So you can see that we have to see this building from elevation point of view from this side. Then this distance is a distance and this is our height of building. Okay, so if we have the value of a, b and h, then we have two ratio. First one is a by b and second one is h by b. Now if our h by b is less than 1, then we have to refer figure number 4b, and if we have the value of h by b greater or equal to 1, then we have to refer figure 4a. Okay, so this is the calculation of CF when the wind load is acting on any RCC building. Now the term is to find out CF when the wind load is acting on any water tank. Okay, so whenever a wind load is acting on any water tank, then you are referring page number 40. So you all the students are moved to page number 40 in which our y axis is written as CF upon 1 plus 2 epsilon by D and x axis is written as RE. Now what is RE? RE means Reynolds numbers. Okay, so how to calculate Reynolds number and after that how to calculate the value of CF will be discussed in our example number 3. Okay, so this is the method of how to calculate CF. In this slide, it is clearly mentioned that when the wind load is acting on water tank, then we have to refer page number. This is a typing mistake. It is 40, 41 and 56. Okay, now we have to find out second unknown, which is effective frontal area. Now effective frontal area Now, effective frontal area can be found out from the equation length perpendicular wind divided by total number of column in that direction. Now, we will discuss with one example. So, you can see that this is your example number 2 of your Atul Prakashan book in which the building is this is your example number 1. So in your example number 1, the building is given as 20-meter cross 30-meter, and obviously you have to design your building having wind load perpendicular to the longer leg. Okay, so if this is 20-meter and this is 30-meter, now length perpendicular to wind. Okay, so length perpendicular to wind, it means your wind direction is this. Now what is this length? This length is 30-meter divided by number of columns in that direction. So you can see that this is 1, 2, 3, 4, 5, 6 and 7. So there are total 7 numbers of column to resist the wind load. Okay, so that's why our effective frontal area is 30 by 7. So it is 4.285 meter. Now one question is arise in your mind is that the area unit is meter square. So generally this value is calculated per meter length. So 30 by 7 into 1. So we have to calculate per meter length. So this answer is also written as 4.285 meter square. Okay. So students, this is the calculation of our step number 3, in which we have to calculate our CF, which is effective frontal area. Sorry, A is our effective frontal area, CF is force coefficient, and PD, which is calculated in our step number 2. Okay, so this is the end of our design step of wind load calculation. Now the term is our example number 1, which is wind load calculation. Now students, in this chapter we have to discuss about 3 examples. In first 2 example is based on when the wind load is acting on any RCC residential building or commercial building, which is high-rise building. And in our example number 3, we have to discuss about when the wind load is acting on any elevated water tank. Now, what is the difference between example number 1 and 2? So in example number 1 and example number 2, there is a difference in the topography. Topography means at which plane area your building has to be designed. It is theta less than 3 degree or theta greater than 3 degree. Okay. So all this discussion will be covered in your next lecture. So this is the end of our today's session. Thank you.